Hi there. I'm John Weirs, one of the lead developers on the OpenEI team, and I'd like to welcome you to OpenEI and Linked Open Data. In this brief presentation, I'll give you a little background on OpenEI and how it uses linked open data in day-to-day operations. Right off the bat, you'll notice some key definitions. OpenEI stands for Open Energy Information, and LOD is the common abbreviation for linked open data. Let's begin, shall we? OpenEI is a free and open knowledge-sharing platform created to provide easy access to energy-related data, models, tools, and information. It was created in 2009 to support the Open Government Initiative and has grown substantially since then. A quick look at these statistics, and it's easy to see that there's a lot going on OpenEI. In fact, I prefer to describe OpenEI as a platform of platforms. OpenEI is simultaneously a powerful crowdsourcing tool, data repository, catalog of information, and a glossary of energy terms. A quick peek under the hood shows the many platforms we're running. Our apps section pulls its data from our wiki area and displays it using Simile Exhibit. Our linked open data area publishes semantic data through the web via a Virtuoso triple store, but more on that later. We're utilizing Drupal and Amazon data storage services in our datasets area, and our wiki runs on MediaWiki, the same underlying technology as Wikipedia. A quick side note, I've noticed some people are apprehensive when it comes to storing information in a wiki, so I'd like to take a moment to explain some of the data quality and audit trail provisions that come with OpenEI. Every page has a full edit and revision history. Every change made to a page shows up in this history with the user's name who made the change and a diff or description of the content that changed, and an option to undo that change. Any change can be undone. Furthermore, any page can be watched by any users. Watching a page notifies the user via email whenever a change has been made to that page. So if you're particularly sensitive about the content of an individual page, you can keep a close digital eye on it. Highly sensitive areas can even be locked down by a review board. In these cases, any user can make a change, but only special users will be allowed to approve those changes. Until they're approved, the changes are not displayed on the public page. Additionally, studies done by Wikipedia and others have found that strong user communities, such as the one OpenEI has, are self-policing. In a recent study, Wikipedia found the average life of a malicious edit on one of their pages to be less than 15 minutes. With all these safeguards in place, the wiki truly can be a viable platform to share scientific data. I mentioned crowdsourcing. I thought I'd take a brief moment to show you an example of crowdsourcing success on OpenEI in the form of utility rates. People often assume that EIA collects utility rate information, but they do not. You may have heard of Desire. Desire actually gets their utility rates from OpenEI. OpenEI has created a system for the collection of utility rates from around the country, and with little help from external data mining partners and an army of interns at several universities, has amassed over 22,000 specific utility rates at the time of this presentation. These data are being pulled through a variety of linked open data mechanisms to be used in government and private industries around the country. The dataset itself is creating new jobs that is being accessed from our linked open data endpoints and then repurposed by entrepreneurs and industry professionals. So, on to linked open data. In this overview slide, you can see some of the high-level benefits of using linked open data. But what exactly does it mean? Well, there's a lot going on here. I'll walk you through it. Without linked open data, each website stores data in its own database. This is pretty typical of the web today. If the sites are talking about the same topic, there's a high likelihood that they're each store the same data in their database. This can lead to duplication of effort. Furthermore, if you want to display somebody else's data, you must download a copy of it, typically in a CSV file or Excel format, and then load it into your database. But if the original site then updates their data, your site is now serving an outdated version of that same information. This can lead to the online community being presented with conflicting information, and unless every piece of information on both sites is time-stamped, how is a user supposed to know which one is more accurate? With linked open data, this is not an issue. Datasets are exposed using an international protocol for information mining. Think of it as an API on steroids. Instead of exposing few key services via traditional API, the database itself is exposed at the database level. It's all about sharing databases. Now, if the original site updates their data, the information on our site is updated instantly, providing a consistent message across the internet. Furthermore, it relieves our developers of the responsibility of updating that data, allowing us to focus our efforts on the information we're best suited to provide. More on that later. An added benefit to LOD is that the third-party site can come along and link into other sites linked to open databases, combining them in what we call a mashup to produce new and exciting data products. Linked open data puts your data to work, fostering innovation and advancing industry. So how does OpenEI use it? One great example is our country pages. From the Browse by Region link on OpenEI's homepage, you can see one of our country pages. There's a lot of information here: population, gross domestic product, renewable potential. And we at OpenEI don't want to be the maintainers of all of that information. Take population, for example. We don't want to have to update our country page on India every time someone is born in India or someone takes a new census in India. So we pull that information in from Wikipedia. In the case of Regal, we're pulling in their policy and regulatory overviews for select countries. You're starting to get the idea. But it's more than just convenience. It's a growing necessity. In this recent quote from IBM, you can get a feel for the coming tsunami of data headed our way. In the very near future, it will be impractical to request a copy of data on hard drive or in an Excel sheet. Imagine trying to perform analysis on real-time, minute-by-minute load data from across the nation. You could request a hard drive be sent to you every hour of every day, or you could simply link to the database using linked open data principles and analyze its contents in real time. Behind the scenes, OpenEI is requesting policy and regulatory information from Regal's linked open data endpoint. In this case, we're using Sparkle, a universal query language designed for querying open databases. Because we're accessing the content at the database level, we're free to reformat it and display it however we like. So how does the computer know which information to return? Well, it's all about semantics. Whenever you hear somebody talk about the semantic web, this is what they're talking about: linking universal concepts together. In this case, the Wikipedia page on India. We can be sure both sides are talking about the same thing because OpenEI says when we're talking about India, we're talking about the same thing Wikipedia is on this specific page about India. Regal does the same thing. The semantic property behind the scenes in this case is called FOF page, but basically it's just letting both OpenEI and Regal know that we're talking about the same topic. By both of us linking to the Wikipedia article on India, the computers can be sure that we're both talking about the same topic and pulling in the right information. If I were to create a page on Georgia and wanted to include the population of Georgia, and you were a computer trying to provide me with that information, you would need to know whether I was talking about the state of Georgia or the country of Georgia. This is where the semantics come into play. Hopefully it's all making sense now, and you've gotten a great overview of OpenEI and linked open data. Thank you for listening, and encourage you to contact me if you have any questions.